Okay, so just a quick optional video here on how do we develop the formula used to do the math for curved mirrors and possibly lenses, because we're going to do some lens stuff later on. So looking at this diagram here, we're going to use similar triangles to do so. So I'm just going to label a few things off here. So you notice that this height here, which is already labeled HI, if I go across over here to where VB is over here, this height and the height over here on the other side, they're both the same. So I'm just going to label this HI as well, just for the sake of our similar triangles. Now, I'm going to look at this blue shaded area first of all. So this area here and this area here, you notice that these two triangles, they share this angle theta. So that's theta. If I were to go across here, if you remember our rules, two intersecting lines, angles on opposite sides are the same. Okay, so these two angles would be the same on either side of this. Okay, because those two angles are the side, and there's a 90 degrees here, and there's a 90 degrees here, these two triangles are technically similar because all the angles would be the same then. So therefore, I can set up a ratio. I can set up a ratio that compares the sides and say this OA triangle here that has the HO here. So I can say HO over a length here, and we have a length here, this length right here, going across. That's a very important length that we're going to use. But you notice that length is not really labeled here from F over to the object. That's not here, but I have F. You can see here I have the focal length. So this is F here. And then I also have DO, which is the total length here going all the way across. If I subtract those two, I should get this piece here. So I can say DO minus F. Okay, so that's this triangle's two sides. And what I'm going to do is I'm going to compare that to the similar triangle on the other side, the right side there, with its corresponding sides. So the vertical piece here, that's opposite the angle. So that's opposite the angle is HI. Opposite this angle is, HO, sorry. This other one's HI. So those two sides correspond to each other. And the piece that's adjacent here, that goes across the bottom, that's DO minus F. The piece here that goes across the bottom, that is F. So that's a starting point for our formula. It compares HO and HI, DO and F. Okay. Now what I'm going to do here is I'm going to sneeze. I was going to sneeze. Oh, sorry, there you go. So I'm going to look at a new triangle now, another similar triangle. And you can see that based on the law of reflection, this angle here, which they label as well, this angle here they label as theta, and this angle here, because the principal axis, this principal axis line is a normal line, these two red angles are the same. So I have a larger similar triangle here. Let's see if I can get it. So I got a similar triangle here. Top triangle, and then I have a triangle on the bottom. All the way down to this one. So these two triangles are similar to each other because they share a same angle. They actually share one angle, that's the same. They actually share all the angles that are the same. They share that these are 90 degrees here, that's 90 degrees here. So this other angle must also be the same. So these are similar triangles. Okay, so we're going to use that now to create another formula or create another relationship here. So I'm going to look at the HI over here on this side. So that's the height of this triangle. The length of this triangle going all the way across is DI. So HI over DI. And the two corresponding sides on the top triangle would be HO over DO. Okay. So what I'm going to do with these two equations now is I'm going to try to somehow put them together. So we've got two similar triangles, the blue similar triangles and my magenta highlighter similar triangles here. And I'm going to take those two formulas and put them together. You can see that they both have HO and HI in it. So what I'm going to do is I'm going to isolate for HO over HI or HI over HO, it doesn't really matter. So I'm going to take this first formula going to just rearrange it to say, well, let's do the HI. HI over HO. So this means I'm going to times up the DI to the other side, instead of DI over DO. Yeah. Technically, this is a formula as well. It's for magnification. There should be a negative in there. We'll deal with that negative part later on. Because the height is negative, if you say up is positive. The height would be, the HI would be negative here. We'll deal with that later. Other things that we have here, let's see, we're going to take the other formula. I'm going to rearrange that for HI over HO. So this formula here, I'm going to rearrange here, HI over HO. So that means that I'm going to have F over DO minus F. Yeah, looking pretty good. Because they're both equal to HI over HO, I can make them equal to each other. Okay, so now they're equal to each other. What I can do now is, what do I want to do now? Oh, yeah, okay, I want to get rid of all my denominators here, or simplify this down just a little bit. So what I'm going to do is I'm going to flip this over. So I'm just going to flip this over. This is going to become DO over DI. I'm just looking at, I have these in my notes. I did the math beforehand, so let's see if it worked out. So that's why I'm looking down. Flip that over. Again, I'm going to separate this side over here. So it says DO over F, and then go minus F over F, which is 1. Okay. I'm going to times the F around. So I'm going to times both sides by F. So I get this situation. Okay, and then I'm going to times both sides by DO, or DI, sorry, to get rid of this denominator here. So I get something like that. So I times both sides by DI to get rid of the denominator of DI. Okay, so my goal right now is to isolate for F. So I'm going to move the minus DI, DIF over to the other side. I'm going to factor out the F. And then I'm going to divide down what I have inside the brackets there. Okay, looking pretty good. Now what I'm going to do with that is I'm going to flip it over again. So I'm going to flip both things over. So flip. This becomes 1 over F, and this side becomes DO plus DI over DO DI. And then I'm going to separate that fraction up. So it's going to say DO over DO DI plus DI over DO DI. And then I'm going to reduce down slightly here. I'm going to take the DOs here and the DIs and cancel those out. So I get 1 over F is equal to 1 over DI plus 1 over DO. And that's my formula. So we have 1 over F is equal to 1 over DI or DO, it doesn't matter, plus 1 over DI. So this formula is going to be useful to help us figure out mathematically what's the distance of the object, what's the distance of the image. Then up here, before we got too far, this formula here is going to help us figure out what the magnification of the object is. Because this is just comparing the height of the image and the height of the object. Now the magnification formula has a negative thrown into it. It's on your formula sheet as well, where it says the magnification is HI over HO, okay? And there's also got a negative di over DO, negative di over DO, okay? Now the negative is thrown in there to help us fix some mathematical glitches that if it's inverted, we want the height to come out as negative. If it's erect, we want the height to come out as positive.